So this is next example. So this example here given for and here an engine running at 150 rpm drives a line shaft by means of the wheel. The engine pulley is a 750 mm diameter and the pulley on the line shaft be 450 mm. So a 900 mm diameter pulley on the line shaft drives a 150 mm diameter pulley keyed to a dynamo shaft. Find the speed of the dynamo shaft where first there is no slip and if there is a slip of 2% at the each time. So N1, so here this is a compoundable drive. This is compoundable drive. So there are 3 shafts. So as previously we also go through this such type of example. There are compoundable drive having 3 shafts. So first shaft, second shaft, and third shaft. So first pulley, which is a driver pulley, which run this driven pulley, second pulley. Now this second pulley is attached to this shaft, second shaft. On the same shaft, another pulley having a different diameter is attached here. So RPM of both the pulleys are same. So this again drive. This becomes now driver pulley, and this driver pulley drive another pulley which is placed on the shaft number 4. Placed on the shaft number 4. So this is the diagram, schematic diagram for this example, which is the compound build drive. So here diameters are given. So here these diameters are given. This D1 is given, D2 is given, D3 is given, D4 is given. And 750 mm, 450 mm, 900 mm, 150 mm. Speed of this engine shaft is given as a 150 rpm. And they asked to find out the speed of this dynamo shaft. And slip is also given as 2% at the each drive. 2% of the each drive. This example we now in this example we have to calculate this N4 by considering no slip, and again we calculate this N4 by considering slip at 2% at each drive. So their first case, this is called this N4 is calculated by considering without no slip. N4 by N1 is equal to D1 by D4 and D3 by D2. This will be considered as a D1 by D4 and D3 by D2. So put all these values, D1, D2, D3, D4 are given to you. N1 is also given to you. So input here calculated 150 into 10, 1500 rpm. So without slip this becomes as a 1500 rpm. Now with slip at 2% at each drive. 2% at each drive. In previous example we calculate by considering slip at different stages. Here in this example. So instead of direct calculating, we first calculating here. We first calculating this into here, and then we move further. So 2 stages we consider, N1 to N2 and again N3 to N4. So you can directly calculate by considering. Now here also slip is considering, but these are converted or divided into 2 parts. N1 to N2 and N3 to N4. Now here instead of converting into the 2 parts, they are calculating in single step. They are calculating in single step as a N4 by N1, D1 by D2 into D3 by D4 into 1 minus S1 by 100, 1 minus S2 by 100. These are calculated in previous example separately from N1 to N2 and N3 to N4 by considering this slip. But here they calculated directly. From N4 by N1 by considering N4 by N1 directly. You can calculate it by in 2 stages also. That answer will be remain same. And here you can calculate it by considering in single step. Then also that answer will be same. So this N4 is calculating by without slip. N4 calculating with slip. So if you look at this, value 1500 rpm here and 1440 rpm here. So if you look at this, so there is a reduction of 60 rpm. Reduction of 60 rpm due to the slip, that are present at the each drive. This is the another example. In this another example, the power is transmitted from a pulley 1 meter diameter running at 200 rpm to a pulley 2.25 meter diameter by means of belt. Find the speed lost by driven pulley as a result of creep. If the stress on the tight and slack side of the belt is 1.4 megapascal and 0.5 megapascal respectively, the Young's modulus for the material of the belt is given as 100 megapascal, and they asked to find the speed lost by driven pulley as a result of creep. So they here in this example, creep consideration is given. In this example, creep term is considered. Here we have to find out that speed without creep, and we have to find out speed of that particular driven pulley with a creep value, and then we will find out the difference in between that two values, with creep and without creep, which is nothing but the speed lost by driven pulley due to the creep. So here this angular velocity formula is same, m2 by n1 is equal to d1 by d2. This for creep, this formula is now changes. For creep, this formula now changes as a E plus square root of sigma 2 divided by E plus square root of sigma 1. This sigma 2 are the stress value on the driven side, and sigma 1 stress value on the driver side. These values are given to you. These values are given as a this 0.5 sigma 1 is given as a 1.4 megapascal. So converted into Newton per meter square. Sigma 2 0.5 megapascal is converted into Newton per meter square. And these are written here. E is the Young's modulus of that particular belt material. So this is also 100 megapascal. So these are converted into Newton per meter square. And written here. D1 by D2. Also D1 is 1 meter is given. D1 is 1 meter. D2 is a 2.25 meter. And this N1 is given as 200 rpm. Put all these values, we will find this rpm. Difference between these two rpm is nothing but a effect of creep on the speed. So speed lost by driven pulley due to the creep is a 0.2 rpm. This example is based on the creep. Term in the belt drive. This example is given. Find the power transmitted by the belt running over the pulley of 100 mm diameter at 200 rpm. The coefficient of friction between the belt and pulley is given as a 0.25. Angle of lap 160 degree, and maximum tension in the belt is a 2500 Newton. So they asked to find out the power transmitted by the belt. Running over a pulley of 600 mm diameter at 200 rpm. So N is given. N and diameter, speed and diameter is given to you. Coefficient of friction is also given to you. And this coefficient of friction is given as a 0.25. Coefficient of friction mu is given as a 0.25. Angle of lap theta is given as a 160 degree. So converted into radian, 160 into pi by 180. Converted into radian. T1 is given as a 2500 Newton. T1 is given as a 2500 Newton. So power formula, in power formula we have power formula as a force into velocity is equal to power. So velocity, or velocity, linear velocity is the linear speed. This velocity, linear speed of that belt v, linear speed of that belt v, we can calculate as a pi dn by 60. V is calculated as a pi dn by 60. So this pi dn by 60, d diameter is given, n is also given. So diameter 0.6 meter is given, n rpm 200 meter is given, n 200 rpm is given, divided by 60. So v is calculated as a 6.284 meter per second. And now in power formula we obtain v value. T value is given to you. Initial tension, maximum tension value is given in the belt is at 2500. So T1 is also known to you, but T2 is not known to you. T2 is not known to you. So another formula having relation in between T1 and T2 is that this formula 2.3 log T1 by T2 is equal to mu theta We have this formula having relation in between T1 and T2, having relation in between T1 and T2. Now in this formula mu and theta should be known, that are given to us. 0.25 and theta 160 degree converted to radian 2.793 radian, these are given to you. So by simplifying this we get T1 by T2 is equal to 2.01. Now T1 by T2 given as a 2.01, T1 is given 2500. So T2 is, we calculate T2 as a 1244 Newton. 1244 Newton. So we put this value here in this formula, and power we can calculate as a 7.89 kilowatt. Power we can calculate as 7.89 kilowatt. Now next example. So in this example, power value, force into velocity we have to calculate. T2 is unknown to you. So to find out T2, we use another relation in between T1 and T2. And then we find T2 value, and we can simplify this, and we can find out power value. Now here in this example, a casting weighing 9 kilonewton. The casting weighing 9 kilonewton hangs freely from a rope which make 2.5 turns round a drum of 300 mm diameter, revolving at 20 rpm. The other end of the rope is pulled by a man. The coefficient of friction is 0.25. Determine first the force required by the man, and second the power to raise the casting. So to find out that power, we know T1, T2 and V. Now here given quantity, if you write this given quantity, weight of that casting, which provide tension to that rope, which hang freely from a rope. So this provide tension to this rope. So this T1 we may consider as a 9 kilonewton, 9000 Newton. Diameter of that pulley is 300 meter is given, converted into meter, 0.3 meter. N is given as a 20 rpm. N is given as a 20, revolving at 20 rpm. This coefficient of friction is given as a 0.20. Now force required by that particular man, that are asking quantity. Force required by that man that are asking quantity, which is nothing but T2. So T1 and T2 relation formula having a relation between T1 and T2 have like this: 2.3 log T1 by T2 is equal to mu theta. So this T1 is known to you. This T1 is known to you. T1 known to you. Mu is known to you. Theta is also known to you. Theta is also known to you. So this theta is calculated like this. Theta is calculated like this. There are 2.5 terms around a drum. 2.5 terms around a drum. So 2.5 into 2 pi. 2.5 into 2 pi. This is a 5 pi. This is the theta. This is theta. Mu is given as a 0.25. T1 is known to you. So unknown is only T2. So this T2 we calculate as a 176.47 Newton. So force required to that man, which is nothing but tension at the other end, which he calculated as a T2 is equal to 176.47 Newton. And now second asking quantity, the power to raise that casting. Now power means that power, we have to know, as we know T1, T2. So velocity of that particular belt or rope, we can calculate as a pi dn by 60. So pi dn by 60, d diameter of that pulley is known to you, n rpm of that pulley is known to you. So v is equal to pi, diameter is 0.3 meter, n is 20 rpm divided by 60, which comes as a 0.3142 meter per second. And then that, as we know to you, T1, T2 known to you, power is nothing but T1 minus T2 into V. So put all these values and you can find out that power is equal to 2772 watt. In kilowatt we can divide by 1000. It becomes 2.772 kilowatt. So this example, though it is asked for rope, for rope also we can use that same formula. And we can simplify this. Or find out the asking quantity. Now this is the sixth example. In this example, the two pulleys, one is a 450 mm diameter and the other is a 200 mm diameter, are on parallel shaft, having distance 1.95 meter apart, and are connected by a crosser belt. Find the length of the belt required and angle of contact in between belt and each pulley. So here length of the belt they are asking, and angle of contact of the belt and each pulley they are asking. When power can be transmitted by the belt when the larger pulley rotated at 200 rpm, revolution per minute rpm, if the maximum permissible tension in the belt is 1 kN and the coefficient of friction in between the belt and pulley is 0.25. So here two pulleys are given, one having diameter 450 mm converted into meter, 0.45 meter, radius divided by 2. Now d2 diameter, other pulley is 200 mm converted into meter, 0.2 meter divided by 2 comes into radius. Center distance between two parallel shafts is given as 1.95. As we discussed earlier, some books are considered that center distance in between shafts as a capital D. Some books are considered that center distance between shafts as a x. So according to that different books, that center distance notation may be changed by D or by x. So you can consider here accordingly. So here they consider that center distance notation as x is equal to 1.95 meter. N2 rpm is given, N1 rpm is given 200 rpm. Initial tension T1 is given 1 kN. Mu value, coefficient of friction 0.25 is given to you. And they asked to find out the length of that particular belt drive. So here crossed belt drive is given, connected by a crossed belt. So length of crossed belt, that formula we can use to find out the length of that particular belt drive. So that formula we here use it. So length is equal to pi into r1 plus r2 plus 2x plus r1 plus r2 square divided by x. And they also asked to find out that angle of contact between the belt and each pulley. So length we can calculate, put that values of R1, R2 value, X value, and you can find out length of the belt. Now here Again, they asked to find out the angle of contact. Angle of contact theta. In crossed belt drive, it is a 180 degree plus 2 alpha. It is 180 degree. Alpha is equal to R1 plus sin alpha is equal to R1 plus R2 by X or D, center distance between pulley. So R1, R2 are known to you, X is known to you. So alpha is equal to 9.6 degree. So theta is now becomes as a 180 degree plus 2 into 9.6. So it becomes 199.2 degree. So in terms of radian, this is the answer. And also power transmitted. They also ask for power transmitted. Now power transmission we are required to calculate. For power transmission we are required to calculate. So here they ask what power can be transmitted by the belt when larger pulley rotated at 200 rpm. If the minimum permissible tension in the belt is 1 kilonewton and coefficient of friction between that belt is a pulley is a 0.25. So here by considering this now here angle of contact theta we can calculate 180 degree plus 2 alpha, and that we can calculate it here. Power transmitted we have to know T1, T2 and V. We have to know T1, T2 and V. V you can calculate T1, T2 and V you can calculate as a pi d1 by 60. V you can calculate as a pi d1 by 60. Here only now remaining is to find out the T2, that formula, that T1 and T2 relation formula, we know that 2.3 log T1 by T2 is equal to mu theta. Mu is given 0.25, theta is given 3.477 radian, that we calculated previously. We put that value here. T1 is given as a 1000 Newton. Now you can find out T2. As soon as you find out T2 value, you put into the power formula, that power formula that we already used as a P is equal to T1 minus T2 into V. So T1 is calculated, T1 is given to you 1000 Newton, T2 you already calculated, V you already calculated. Just put all this value and you can find out the power. That power value, here it is not shown in this PPT, but the power value comes as a 2.74 kilowatt. Here that power value comes as a 2.74 kilowatt. Here it is not pasted in this PPT. This power value comes as a 2.74 kilowatt. So your task is a calculating T2. As soon as you calculating T2, T1 minus T2 into V, that power is nothing but a 2.74 kilowatt.